So now let's try to build some visualizations. So if I were to visualize this X and Y, which are both numbers, the immediate response or the first data visualization that comes to my mind will be line chart, right? Because X is growing monotonically or X is growing in one direction and Y has some values in it. So maybe our line chart is a proper way to represent this. And if I use this recommended charts option, maybe that's what it recommends anyway, right? Most of the time, understand what will be the best chart type for your selected data. So I usually just begin with the recommended chart. And if it doesn't give me the right chart that I'm looking for, then only I will go for the other ones. So we have got x-axis and y-axis, and I can see this is how things look like. And if I look at this chart, I can easily tell that, okay, there is definitely a relationship between the x variable and y variable, right? Because it's just monotonically increasing. Graphs as well will help us gain some of those insights. But what I would also like to say is graphs sometimes can be a bit more misleading, or there could be some inherent relationship or a bit more complicated relationship that you cannot deduce from the graph alone. So I won't just trust the graph alone. So if I just look at the graph and say, okay, there doesn't seem to be any pattern, but when we do the statistical test, then it might indicate that there is some pattern. Or it could be the other way around, where you see some patterns in the graph, but the statistics that there is no relationship between those things. So I will use both in conjunction. So I will also use these graphs for my exploration to figure out whether there are some interesting relationships or not. But I will also do the statistical test at the same time, because statistical tests are more reliable than just visually seeing the graph and deducing that there is a relationship or not. Right? But it does help, or it just guides us in the right direction, whether we should follow it any further or not. And we can definitely just change the type. So I can convert it into a scatter plot. And scatter plot probably is also a good choice for this one, especially if these numbers are being jumbled around, then the scatter plot would make more sense. And by now insert a scatter plot, that would probably make more sense, right? So if I look at this kind of plot, it gives me an indication that there's probably a line I can fit in here. Like we don't even need to go to regression. What we can do is I can use this plus icon and I can just add a line from here. And in that trend line, I can also say, okay, whether it's linear or whatever, right? So I want it to be linear, and I can ask it to display the equation on the chart, and I can ask it to also show the R square. And I can move it here. And now I already have the fit line on that graph, and I can look at its R square, and it's close to 1. So I can tell that this is a really good relationship. Okay, so you can easily add these kind of lines in there. And sometimes it's not the linear line that fits it the best. Maybe the relationship is quadratic. Right? If the relationship is quadratic, for example, let's change this relationship to be quadratic, then what will happen is the relationship now is no longer linear. It's quadratic because it is depending on the square of x, not the value of x itself. So even if we do a linear regression, it seems like we have a good fit, but maybe there are other options, right? So if I change it to exponential, that looks a little bit better because linear had R square of 0.85, exponential have a R square of 0.88. So exponential seems to be a little bit better on this one. But let's try polynomial because we know the relationship is polynomial, and boom, there we go. We've got a square of 0.9. So that way you can easily use this to explore the relationship and try out other form of relationships as well, because relationships are not always linear. It can be exponential, it can be logarithmic, it can be anything, right? So you can try to explore those kind of different relationships and figure out which relationship works the best in this case. Right? And that seems to do better than the linear line. Right? Yeah. And then I can change it to polynomial. And then I will display the equation and R square in the chart so that I know this is the best fit that I can get. because we know that the relationship is quadratic. But even when we don't know the relationship, this is how I will do it. I will explore and check all of that and check linear, 0.85. Yeah, it's okay. Logarithmic gives me 0.6. That's bad. That's not going to work. Power gives me 0.83. That's even worse than the linear, so I won't care about that. Exponential gives me 0.88. That's good. That's better than linear. But polynomial gives me the best when with order of 2 because it gets me 0.9. But if I change this order to order 3, it gives me 0.95. So it just complicates the equation, but the R² value doesn't change much, which means that, okay, maybe it's not worth overcomplicating it, right? Because we can keep going and then increase the order to 4, 5, and then it would probably stay the same. The R² doesn't change much, which means that we need to pick the simplest one that gives you the best R². Don't try to overcomplicate the relationship because simple relationships are always better. It's easy to explain rather than trying all those complex one, which becomes even harder and harder to explain. Yeah, you probably need this sample data, but you can probably just try with random data anyway. And yeah, even if the R² is not good, it doesn't matter. Just try to add a trend line and make sure you can see the equation. That's probably what we want. And just remember this kind of layout as well, because this is the exact interface that Power BI has. So on Power BI as well, on each visual, you will see these kind of buttons and they work the same way there as well. So you can do axis titles, you can add data labels, you can add relation, you can add trend line, and what we're talking about. Yeah, that's how we can quickly add trend lines and just explore what sort of relationship will fit the data the best. And we use it quite a lot because when we go to linear regression, we first need to know what sort of regression will we want to fit it, whether it's a linear, whether it's quadratic, whether it's multiple linear regression, all those kind of things. So, and this is a really quick way of exploring that. And obviously there are other kind of graphs. So for example, let's just say category, and then there is like number or whatever it is, and then category A, B, C, D, and they're probably a number like random numbers, whatever they are. So if one of the value is categorical and then the other value is numerical, then the kind of graph that we use is bar chart. Right? If there are not much categories, we can use pie chart as well. But most of the time, we just go with bar chart. Because there are other caveats on using pie chart, is that if the total sum of all these categories, if that makes sense, then it would make sense to put it into, otherwise it won't make sense to put it into a bar chart. And with that, we can do, all these things. The same as the other one, we can add the data labels, we can add a legend, we can add trend line and all those kind of things. But what if there were some subcategory? So if there were some subcategories, like maybe this is subcategory 1, this is subcategory 2, subcategory 3, this is subcategory 1. And again, A has subcategory 2, and there is some random number. B has some subcategory 3, and it has got some number. D has some subcategory 2, and it has got some number. Right? So what if it has got those categories and subcategories? Then that's when we will start to use the clustered bar chart or stacked bar charts. And what that will do is, that's the bar chart I was after. There you go, bar chart, and we will look for a stacked bar chart. So previously we only have bar chart A, B, C, and D. Now within the category A, B, C, and D, there are subcategories, and we want to look at the subcategories as well. And so within A, how much of the portion was made by subcategory 1, and how much of the portion was made from subcategory 2? If that's the kind of analysis that we want to do, then we will use this kind of stacked bar chart. And again, this kind of thing keeps coming over and over again, so we will look into them a lot later. And one of the things that we want to learn here as well is things like this box and whisker plot. And I think we had a chat about this one when we were talking about in that data analysis basics section. So what this box and whisker plot does, it helps us identify outliers. Okay. So this is the value y. And then currently there seems like there are no outliers because all of them are in expected range. Right? So it goes from 1 all the way up to maybe 4 and lower than that. But what would happen if there was a certain case where it was not in this range? So maybe one of them was like 40. Then that will be out of range because all the other values are in this particular range. And that will tell you that's an outlier. And it could be there for different reasons. Maybe someone typed it wrong. Maybe it wasn't supposed to be 4.0, and maybe it was even supposed to be 0.4, but someone typed in as 40. And that's probably why we have this issue, right? So instead of 40, if it was 4.0, that probably would have been in the range, right? But because it was way outside, we can use this kind of tools, this kind of visualization to identify as outliers. So even if it was 10, I think it would be an outlier because all the other values are expected to be like somewhere in between 0 and 5. Right? So there are these kind of tools, these kind of visualizations, which help us quickly identify these kind of anomalies as well. Right? But again, these are the kind of visualizations that exist, right? Which helps you identify trends or identify outliers, all those kind of things. And what we can also do is we can click on one of these ones. And let's say I was interested in looking at its distribution. So I want to look how the data is distributed, right? So from between 0.12 to 1.3, there are this many data. Between this and this, there are this many data and so on. And I think I can change the number of bins. Right? So if I want to change the number of bins to maybe 10, then it would adjust it automatically and give me a distribution of how it looks like when I maybe do 10 bins. Right? So this is how the data looks like, or I can define the bin width and I want the bin width to be maybe 0.1. Right? Okay, between 0.1 and 0.2, there are this many numbers. Between 0.1 and 0.3, there are this many numbers and so on. And if I now change the bin size, where did that go? Then hopefully that will make more sense. Okay, this is how many data there are in between 0.12 and 0.42. There is how many data there are between 0.42 and 0.72 and so on. And that's where we start to see those kind of frequency distribution of the data. And looking at this kind of frequency distribution is really important when we start getting into those kind of frequency distributions like normal distribution or binomial distribution or exponential distribution and so on. Because depending on what sort of distribution your data follows, the kind of statistical analysis that we do will be different. Because a lot of things about the data relies on this kind of frequency distribution, right? So if it is a normal distribution, there are certain assumptions we can make about this normal distribution. If the data is not normally distributed, then there would be some other assumptions that we need to make about that data, right? So being able to build this kind of frequency distribution is really important because this will dictate a lot of the other subsequent work that we do with this data. You just select the data that you want to visualize, you go to insert, and then you go to histogram and just click on the histogram. And after that, you can decide how you want to bin the data. So do you want to bin automatically? Do you want to bin with specific width? Or do you want to define how many number of bins that you want to see? Maybe I just want to see 10 number of bins. Or adjust the bin width to give me exactly 10 number of bins. If your data has numbers that are way out of range or outside of the boundary, you can also define overflow bins. You can say that, okay, anything that is above that goes to this overflow bin. And you can have underflow bins as well and say, okay, anything below this goes to this underflow bin. So you can add those overflows and underflow bins as well. But most of the time, we'll just probably worry about number of bins that we want, or we just change the bin width so that we can get whatever number of bins we want. And that's what we do with histogram. It represents the frequency of occurrence of the data. And some other charts that we will find helpful is bar charts most of the time, line charts, histogram, we use them a lot as well. Scatter plot, we use them a lot. And probably those are the basic visualizations we use most of the time. And we'll probably come across other visualizations as we need and come back and I will show you a bit more detail about those visualizations. Need them. Yeah, I think we covered almost everything we wanted to cover for Excel. There are some project ideas if you want to give them a shot. But I think it's almost it for all the topics that we wanted to cover in Excel. I know we haven't touched on everything in Excel, but these are just the generic things that we use quite often in our analytics work. And there are a few things that we skipped over or didn't spend much time on today because we will spend a lot more time on that when we do these particular sections like data cleaning. So when we are doing data cleaning, we revisit Excel again and say that, okay, this is how we do data cleaning. So how would you do that data cleaning using Excel? And I will show you how you will do that here. When we do the data transformation, it will be the exact same thing. So these are the kind of transformations you need to do. But how will you do that in Excel? I will show you how to do those things in Excel. Same with stats as well. We will learn something about statistics, and then I will show you, okay, so if you need to do this kind of statistic analysis in Excel, this is how you will do it. So we'll always keep revisiting these tools.